Hi everyone, this is presentation for assignment 1 data mining project. We are group 34 and these are the name of people in the group who is presenting this. The data set which was chosen for this project was of the weather condition between 2006 and 2016 in Siege, which is a city in Hungary. The data contained the hourly summary of the variables such as date, temperature, apparent temperature, summary. Summary is actually a parameter which indicates a type of a day and many more. In short, there are 11 columns in the data. It is not mentioned anywhere how this data was recorded, but obviously some of the scientific method or devices such as radar system, barometer, rain gauges might be used. This data set contains about 96,454 values in total. The values were recorded in consecutive hours, but they are not arranged in the order that the day which comes after is below, and there are many missing dates as well. There are many discrepancies in the data values, such as humidity at some point was 0 and also 1, which is practically not true and not possible. Taking this into consideration, it is decided to start with data cleansing initially in the data exploratory analysis. Over to Avneet for data cleansing.
Yeah. We have 96,000 value approximately in our data set, and which gives a lot of variables to us to show in the graphical representation. But with it, it also gives us some errors. Like it gives us some unnecessary data columns, which is including like cloud cover, daily summary, and there's some outliers as well in the humidity and pressure. And there's some missing values inside it, precip type, data type. So as we can see from heat map, there's a little line over here which showing that there's a number of this much of value is missing from the data set, and which we can easily be shown it from here as well. Here's a box plot for the outliers. This is for the humidity. That's showing this much is the values is going out of the proper values, and these for the pressure. We have a Python commands to refine our data, as we have used mode to define to fill the null values, as it can calculate the number of occurrences, maximum occurrences in that column, and it can automatically fill all the data which is maximally occurring. We don't use the deletion method because it can delete the other data as well. And for the duplicate droplets, we use df.drop duplicates, which drops all the duplicates. And we have df.pop, which drop whole column, which we don't use because as it's unnecessary data in it. As we can see, there's a box plot for the cleared outliers. There's not any other outliers and data is clean. And there's also a heat map which showing there's a no null value inside it now. Over to Rushit.
Pearson's coefficient is the best statistic value that measures the statistical relationship or association between two any continuous variables. As majority of our attributes are continuous values, Pearson's value gave us an overview about how any two variables are related to one another. This matrix of Pearson's value was our base to find out about the patterns and abnormality in the weather of Siege. Based on relationship established, we have made relevant graphs and verified if the hypothesis happen to be correct or not. Next slide, please. Moving on to our first hypothesis, that is, humidity is inversely proportional to visibility. As it is observed from graph, relationship between them is not so strong as the plots are sparsely distributed all over the graph. And same is evident from Pearson's correlation value, which is near to negative of 2. The research conducted in the report also states that with high humidity, there happens to be microscopic water particles in the air. Also, when the weather is foggy, when there is high humidity. Thus, we can conclude that the hypothesis is correct, and with the increase in humidity, there is decrease in visibility. Now, I'll hand over to Satvik, who will present more of hypothesis.
My name is Satvik Sharma, and I would be explaining the next couple of slides covering up the leftover hypothesis. The first one is between humidity and pressure. I hypothesized that the humidity would be inversely proportional to pressure. At a constant temperature, the water vapors are less dense than the dry air. As the humidity increases, the water vapor content in the air particles increases. The increase in water vapors in the air molecules decreases the overall density of air, and hence the pressure decreases. The correlation coefficient came out to be was 0.005, which is almost near to zero, which means that the humidity and pressure are not dependent to each other at a very high extent. This might be due to the position and weather conditions of seed. Next slide, please. The second hypothesis was that the pressure is directly proportional to temperature. According to the ideal gas law, PV equal to nRT, at a constant volume, the pressure should directly relate to temperature. As the temperature increases, the pressure should increase as well, and vice versa. But after looking at the graph, the correlation coefficient found out to be was negative 0.290, which indicates that the pressure is inversely proportional to temperature. This is totally different from what the hypothesis was, and the reason for this might be a non-constant volume for the city of C. Now I'm forwarding it to Ishan for the explanation of relationships between the factors that affect the weather.
Hi, I'm Ishan, and I'm gonna investigate some of the important correlations that we found in our data set. Since pressure and temperature are not strongly correlated, we investigated the graph relationship between temperature and humidity to find its correlation. We plotted the temperature versus humidity graph as it can be seen on the screen. The Pearson coefficient was found to be minus 0.59. The negative sign here indicates that the relationship is inversely proportional, which means when temperature increases, humidity will decrease and vice versa. The magnitude is 0.59, which is quite strong and indicates that their relationship is quite strong. Next slide, please. The relationship between wind speed and wind bearing was explored during this slide, and it was visualized using graphs. It is assumed that wind speed may have some relationship with wind bearing, which is the direction of the wind. The above graph is the scatter plot for wind speed and wind bearing values. And the Pearson coefficient for these variables was found to be 0.0085. Now, as you can see, it's positive, which means it's directly proportional. But as their magnitude is very small, which is approaching zero, so we can say that they don't correlate much or at all. Now I'm gonna hand over to Dharya for more of the correlations.
Yeah, thanks, Ishan. So I'll take over the slides from now. So talking about the relationship between temperature and apparent temperature, the Pearson correlation coefficient come out to be 0.994. And from the observation of graph, we can state that the temperature and apparent temperature are positively correlated, which implies that they are directly proportional. In terms of the strength of the relationship, the graph shows that the data points form an upward slope and a straight line, indicating that it's a very strong positive relationship, which justifies the scientific reason to it. The combined effects of air temperature, relative humidity, and wind speed produce apparent temperature. We can conclude they have a very strong positive relationship. In conclusion, next please. In conclusion, we performed exploratory data analysis to the weather data set. The analysis included data cleaning, finding correlations, identifying different patterns, checking the hypothesis, and developing visualization. So at last, we concluded some observations. Number one, the correlation between humidity and temperature comes out to be negative, which implies they are inversely proportional. Number two, theoretically, wind speed does not get affected from wind bearing. When graph is plotted, their correlation portray the same result, showing very slight positive correlation. And number three, strong conclusion is that data analysis confirm more rainfall than snowfall. That's it for my conclusion. Thank you.
There are some general questions about our data, that why we use this data. This data is very huge, and there's a lot of number of data sets which we can use for the graphical representation and show the different approaches to clean the data. By which approach we use to clean the data? We use the node method to fill all the null values, because node is the best for the categorical data, because the precip type has some null values. That's why we use the node in it. And we used list and deletion for duplicates, so we can delete all the duplicates. What did we use to plot the graph? We use Plotly and Seaborn, as there are two libraries which we can use different type of graphs, like plot graph, bar graph, and scatter graph, to show the different representation of the data on the graph. Why we use that method only to show the graph? We used bar graph maximally to show the representation of our data set because it show all the correct data on our graph. So, and it also have some different subgroups dividends. So we can see like this this group has this much data of variance, and this graph has this much variance in it. Yeah, that's it.
Thank you.